Hello everybody, welcome to 321. We have finished our first week and I wanted to go over some of the aspects of anatomy of a scientific article, ways you can approach it, and hopefully get you a little more comfortable with reading scientific literature. So first of all, you might have noticed when it comes to reading these sorts of articles versus something you may be more familiar with, it's a matter of tone. When we're talking about scientific literature, we have very specific words that we use in very specific ways that we present things. So think about the difference between other forms of communication. This is nothing really new. The way you talk to a friend in a text message is not how you're going to email your boss. A letter to grandma is going to be different than a book report for class, and a conversation on the bus is going to be different than the stuff you talk about for a job interview. So these differences represent the tone of the communication, and that's the same thing for scientific literature and reading journal articles. What we're trying to do with scientific writing kind of dictates this tone, and that's presenting new ideas, new methods, and new findings. But you should not be reading this the same way you would fiction, entertainment, or even popular news media. What a research article's main goal is to do is to kind of tell you the story of the research. But in order to do that, there's, like I said, some very specific structures that they have in place. So we need to understand those structures. What makes up a research article? What makes a research article different than some other articles? And how to recognize a strong one versus a weak one when it comes to research. The main parts of a paper are introduction, body, and conclusion, and we may remember this from early on in primary school or writing classes that we took in college or some other time. Introduction introduces a topic, goes from broad to specific. The body has kind of the supporting subtopics with a topic sentence for each paragraph. Don't forget about topic sentences. And then the conclusion wraps things up and tells you what the whole point was and how it was made, and is a nice tidy end. So scientific writing isn't much different. Here, however, we have these new sections called the abstract, methods, and results. And the methods and results really take the body and kind of formalize the presentation of information within the body of traditional writing. So let's look at each one of these. The abstract is usually a limited amount of words that you can use to kind of convey what's going on. Think of this like the preview to a movie, if you will. You can't give away the whole movie, you give a preview. Well, you can't give away the whole paper, you give an abstract. With the abstract, you want some of the same things. What is being tested, how it was being tested, and some of the findings. But you don't want to give away too much or else nobody would read your article. We hop next into the introduction. This outlines the problem. It reviews what's been done up to this point. Just like you've been doing with your lit review, it takes a whole bunch of different pieces of literature or manuscripts in the area and tries to find common threads. It also presents specific expectations. This is a prediction, if you will, in the form of a hypothesis that comes from some of the questions that the lit review helps clarify and present. Ties together past research with current study and expected results, and it builds a case for conducting the study. The methods section contains numerous subsections at times, but what should be outlined are the experimental design, how many people are you testing, and what are you testing them on. Now with experimental design, we'll get into this more, but are you testing the same people over and over again? Are there distinct groups that have different conditions? What are you splitting them out by? The participants, how many are you going to involve in this research, and where do they come from and why? And what are you going to measure them on? Do you care about their IQ? Do you care about their age? Do you care about their depression scores? Those sorts of things. Ideally, if this is done well, this entire study should be able to be replicated from this section alone. So it's a really, really important section in scientific writing. After the methods, or the early parts of the methods, come the results. This is where findings are presented. All the stats software that you run on your data, the report of coefficients and p-values and confidence intervals and effect sizes, all that sort of stuff is going to go in the results. Some interpretation of coefficients is okay here, but this should really be limited to clarification, not inference. And that's because the inference usually comes in the discussion and conclusion. Now, some people split these up. Some people merge discussion with results. I do that an awful lot, where I present a result and then I discuss what it means. But the point overall is to explain the implications of the results section. What do all of these statistics mean regarding the hypothesis? Because remember, from the intro, the hypothesis was the main question of the entire study. So all of this should feed back into that hypothesis in some way. Gives the major findings of the study and what the broader implications of these findings are. And it talks about implications, limitations, future directions, all that sort of stuff. So that's the main anatomy of an article. Now we kind of whizzed through that a bit, and there's more information available in the book on this, and you'll kind of get a feel for what's going on. But now let's talk about some of the ways you can approach these articles to get the most out of them. You need to know why you're doing it. Why am I reading scientific literature to begin with? Is this for a project? Is this for a paper that I'm writing, a presentation I'm giving, to learn more? Whatever the purpose is, you need to understand that you have a very specific purpose in doing this. What do you hope to get out of it? Are you hoping to understand a theory or understand a finding? Are you looking for good results or examples that support your hypotheses in your work? All of these are really important things to think about before you start reading scientific literature. Understand the main points and new claims that are being presented in an article, and this comes through the abstract and introduction. It requires a large amount of background information, so if you can, don't skip the introduction. This is where all that background information comes together. They kind of make the connections among different pieces of literature. They find some gaps and they justify what the study is presenting, why we should care about the question that they present in their hypothesis. Look for habits of the writer as well, whether they follow any sort of pattern of, an overview for a section, if they do, like I do, present a finding and then discuss it immediately afterwards. How are the data presented? And pay attention to footnotes as well. Footnotes are very, very helpful, and they're intended to elaborate a point or provide supporting evidence. Keep in mind that reading is only this first step. You need to break this stuff up if it's something that you don't want to just hop right into and do it all at once. So if you can break it up into small chunks, it'll help your comprehension and it'll help your motivation, honestly. Don't worry if you need to reread things multiple times. I do that myself. Friends of mine blog about all of the different articles that they read. And related to that point, you should be thinking seriously about taking notes. I mean, taking notes while you read can help you when you come back to an article, hop right on in without having to reread a bunch of stuff. And you're building up your understanding of a substantive area, so why not take notes on it? So that being said, taking notes, here are some questions to keep in mind. When taking notes, what do you hope to get out of the article? What do you hope it will answer? What did the authors conclude? Why did they do the study? What results emerged? How did they do the study? Again, this gets to design. What is the significance of the findings? Are the implications really big? Is this going to cure cancer, or is this just kind of a, oh, wow, that's interesting sort of finding? How does the article relate to other articles I've read? That's an important question to keep in mind too, kind of building your conceptual understanding of a research topic or area. It's good to know what articles fit into kind of what sections. Did the article answer my question? If so, how? And then other articles to read. And that's a really important part of reading scientific literature, is to find what other scientific literature to read. It can feel a bit like a rabbit hole at times, but it's well worth it. So here are just some tips I've come across over the years. Read the abstract and discussion first. If it sounds like something that you're interested in, keep reading. If you're still unsure, read part of the intro. A well-written article, additionally, will have topic sentences for every single one of its paragraphs. So you could get away with just reading the first sentence of each paragraph or the first few sentences of each paragraph. And you should understand what's going on in the journal article. That's a really helpful tip that somebody gave me a while ago. So I'm passing it on to you. Look for related articles that are cited in the introduction. If the paper makes a great point, follow the trail. Everything that they cite is going to be in the reference list. And along these lines, textbooks have bibliographies as well. So you can find some really great articles, kind of fundamental articles. Usually textbooks are not super cutting edge with what just was published, but they're good for finding historically meaningful articles in research. There are also these things called meta-analyses or review articles as well, or another one. You've probably found one. You should have found one from the first assignment. So very, very helpful style article is these meta-analyses. They can be really difficult to get through, I'm not going to lie. But when you reread them and you start to understand them, you'll see what a wealth of information is available there. Finally, keep in mind that this is hard at first. Nobody just hops into a scientific area and just knows what to do immediately. Get a dictionary, because there's going to be a lot of words that you may not be familiar with, or they're used in peculiar ways. I use dictionary.reference.com an awful lot. There's also Merriam-Webster online, or you could just get a plain old school dictionary, that you'll leaf through. Don't speed read. Nobody's going to be clocking how quickly you get through each article, so don't worry about it. It's not a competition like that. You want quality over quantity. You really want to understand what's going on, not just have read every word. So take notes as you go, talk it out with other people if you can, and keep at it. And like I said before, take it in small chunks, because this can be really, really dense stuff. If you're still having problems, there's a bunch of resources online. You could get these through Google or Bing or whatever your favorite search engine is. So there's a lot of resources available. There's a lot of people available as well. I'm sure your classmates are going to want to talk through stuff as well when you do your peer reviews and some of your collaborative work. So that's the anatomy of an article and some of the strategies you can take for approaching how to read it. I hope this was helpful.